Hello everyone. In this lecture, I am going to discuss how to solve the problems for laterally unsupported beam. For laterally unsupported beam, the first step will be to determine the factored load. So, just like in the case of laterally supported, what we will do, we will multiply the working load. We will multiply the working load by 1.5. After determining the factored load, we will calculate the maximum moment and maximum shear force. In case of UDL, the maximum bending moment will be WL square divided by 8. And in case of point load, this maximum moment you can take as WL by 4. And similarly, for shear force, the maximum shear force due to UDL load is WL by 2, and due to point load, it should be W by 2. Here L is effective length, and effective length can be calculated as clear span plus bearing thickness. And if not given, the bearing thickness can be assumed as 230 mm. This is in fact the thickness of the masonry brick wall. So this is the thickness of the brick wall. So we assume that our beam will rest on this, and this area right over here is the bearing area. After calculating the maximum bending moment and maximum shear force, the next step will be to determine the plastic section modulus. So the plastic section modulus can be calculated using the formula ZP required equal to maximum bending moment times gamma m naught divided by Fy. So this is obtained in step number 2. The value of gamma m naught is 1.1 and the value of Fy is 250 MPa. So one thing that you have to note is you have to keep the same unit for the moment, and this basically the unit should be consistent. After determining the plastic section modulus required, we can select a suitable section from page, like from table 46, page number 70 for Nepalese students. After that, we will be classifying the section using table 2 of IS 800. So in table 2, the classification is done like here. The ratio of B by TF is calculated, and B by TF will be BF divided by 2 TF, because this B is equal to BF by 2, where BF is the flange width. So we calculate this ratio and we check whether it is plastic, compact or semi-compact. After that, we check for the web also, and we find the ratio D over TW. Here D is H minus 2 times of thickness of flange, and TW is the thickness of web. So using this ratio, we can calculate again whether the web is plastic, compact or semi-compact. Like if the value is less than 9.4, then it is plastic. If the value is less than 10.5, it is compact, and 15.7 semi-compact for the flange. and for the wave the values are 84, 105 and 126. Once the section is classified, then we will calculate the value of design shear strength. Design shear strength can be calculated as Fy times area of wave divided by root 3 gamma m naught. This Fy is 250 MPa, gamma m naught is 1.1, and this term Aw is nothing but height into thickness of wave. Now, after calculating design shear strength, we will calculate design like moment capacity. So for moment capacity, we will calculate it just like the supported one, but if the value of this lambda lt is greater than 0.4, then the MD will be calculated using this expression, else it will be done same like the supported one. But if the value of lambda lt is greater than 0.4, then we will use this term. Here beta b is 1 if the section is plastic and compact. So how we will know plastic or compact? We did in step 5 already. So beta b will be 1 if the section is plastic, and the ratio for semi-compact is ZE by ZP. And ZP is basically the plastic section modulus, which can be found from table 46. There it will be under ZPZ. FBD, this FBD can be calculated using these formulas. So there are a lot of formulas. So how we should initiate? So first of all, I have numbered like the sequence in which they have to be calculated. So first of all, we will calculate FCRB, and it is in clause. This is a screenshot of the IS code only. So the first step, we will calculate FCRB. So it can be calculated as 1.1 times pi square. E is 200 GPa. Okay, E is 200 GPa. LLT. What is LLT? It is nothing but K times of L, and this K is 1 for the case of simply supported beam. L is basically L effective, or it will be given to us. Now this Ry is the radius of gyration about y axis. 1 plus 1 by 20. LLT we already discussed. Ry discussed. HF is center to center distance between the flange, and center to center distance between the flange can be calculated as HF equal to H minus thickness of flange. Okay, because for I section, so let's draw the I section. This is given to us H, and we need this distance like from half. So we need this one. So HF, that is H minus this half, and half is TF. Okay, so TF is the thickness of flange. So after calculating that, we will use this like Fy 250 divided by this value to calculate lambda LT, and after that we will calculate like phi LT, and phi LT can be calculated as 0.5 1 plus alpha LT. Alpha is like 0.21 in our case if it is rolled, and we will solve for rolled, and alpha LT is like 0.21. Lambda LT we already calculated here. This is also here, so we can calculate this. We will put this here, and this lambda LT we will be putting here, so to calculate xi LT, and this xi LT we will put here, and we can calculate FBD, and this FBD can be used here, and we can calculate the design moment. So this is the first approach. Okay, so this is the first approach. There is another approach also if we want to get rid of this formula. So we can do that using these tables, like table 14. FCR can be calculated. Here the KL by L, KL by R value is given. Here KL by RY. So 10, 20, like, and this is H divided by TF. So interpolation can be done to determine the FCR values. So I wanted to discuss one thing, that what happens if, let's say, this KL divided by R equal to 10.8 and this H by TF, this ratio is equal to 8.5. Like this is 8.5 in between these two and this is 10.8 in between these two. So in that case we will do two-step interpolation. That is, first of all we will fix this. Let's say we will calculate KL by R and here H by TF, and here will be 10, here let's say 2255.1.2, then there will be 10.8 for which we have to calculate, and then there will be this 20 and the value will be 6220.5. So first of all this is corresponding to 8. So we will calculate the value of X, and similarly again we will calculate for 10 one also. Like for 10 here we will use 2255.1. let's say here is X2, X1, and the value will be 5947.9. so first of all we will take these two and we will calculate X1. Okay, so again we will take these two, then we will calculate X2. So now what happens is we have calculated for 10.1 corresponding to 8 and 10. Now we will again do interpolation, and this time what we will do, we will keep H by TF now as variable and this FCR as the second term. Okay, FCR, and for H by TF equal to 8, the corresponding value of X1 will be kept here, and similarly for 10 X2 will be kept here, and for 8.5 let's say this is Y1, and this Y1 we will calculate again, and this Y1 will be basically for 10.8 and 8.5. I hope it is clear. And for Nepalese audience I am again going to tell in Nepalese. So यो क्वेसन सल्भ गर्दाखेरि यदि हामीलाई लेट्स से केएल बाई आर गर्यौँ हामीले है, केएल बाई आर गर्दाखेरि 10.8 आयो र एच बाई टिएफ गर्दाखेरि 8.5 आयो। अब हेर्नु त यसमा पनि यो दुईटाको बिचमा लाई गर्यो, यसमा पनि यो दुईटाको बिचमा लाई गर्यो। अब यतिखेर हामीले के गर्न पर्छ, हामीले इन्टरपोलेसन दुई स्टेपमा कन्टिन्यू गर्न पर्ने हुन्छ। सो टु स्टेपमा कन्टिन्यू गर्नको लागि हामीले के गर्छौँ, सो सबैभन्दा पहिला लेट्स से मैले के गर्छु, आई विल जस्ट फिक्स दिस। लेट्स से मैले 8 को करस्पोन्डिङमा निकाल्छु है। सो मैले के गर्छु, जस्ट 8 को करस्पोन्डिङमा निकाल्छु। हेर्नु त, सो 10 हुँदाखेरि है, अनि 8 को करस्पोन्डिङमा एफसीआर कति हुन्छ त्यो निकाल्छु मैले। 10 हैन, यता 20 छ, यता 10.8 कहिले निकाल्ने, अनि यो भ्यालु त मलाई दिएको छ, यो दिएको छ, जस्ट यो x1 मलाई थाहा छैन। सो 8 को करस्पोन्डिङमा निकाले एकचोटी, अनि एकचोटी फेरि मैले 10 को करस्पोन्डिङमा पनि निकाल्छु के यो भ्यालुलाई x2। लेट्स से 8 को करस्पोन्डिङमा 10.8 को लागि मेरो x1 आयो र 10 लेख्दाखेरि x2 आयो। अब मैले के गर्छु, h बाई tf लाई भ्यारी गर्छु के, यहाँ मैले 8 राख्छु अनि यहाँ मैले 10 राख्छु, अनि 8 मा कति आएको थियो भ्यालु, x1 आएको थियो, अनि यता फेरि x2 आएको थियो। अब मलाई कतिमा चाहिएछ, 8.5 मा चाहिएछ। सो मैले 8.5 मा लेट्स से y निकाल्छु, अनि यो y भनेको मेरो के हुन्छ, यो y भनेको 10.8 र 8.5 कम्बिनेसनको लागि y भ्यालु आयो के। यसरी हामीले चाहिँ टु स्टेपमा इन्टरपोलेसन गर्न सकिन्छ, अनि वी क्यान क्याल्कुलेट द भ्यालु अफ एफसीआर। र एफसीआर निकाल्यो भने सिमिलरली टेबल नम्बर 14 अब ए मा फेरि एफबिडी पनि दिएको छ कि एफबिडी पनि दिएको छ अनि एफबिडीको लागि पनि सिमिलर टेबल छ KL/R र यहाँ चाहिँ फेरि आई थिङ्क FCR छ अनि त्यसमा पनि यस्तै 2 स्टेप इन्टरपोलेसन गरेर हामीले एफबिडी निकाल्न सक्छौँ र एफबिडी निक्लियो भने चाहिँ हाम्रो प्रब्लम सल्भ भएको मानिन्छ। अब एमडी निक्लिन्छ, एमडी निस्किसकेपछि त्यही हाम्रो लेटरली सपोर्टेड जस्तै इक्जाम्पल लिएर, इनफ्याक्ट यहाँ मैले टाइप गर्न भ्याएको छैन, इट इज अनसपोर्टेड है। सो यहाँ डेल्टा सेम फर्मुला लाग्छ पुरानो फर्मुला जस्तै अनि यो पनि सेम पुरानो एन्ड दिस इज अल्सो द सेम ओल्डर वान एन्ड दिस प्रब्लम विल बी सल्भ। आई होप दिस इज क्लियर फर यु अल। थ्याङ्क यू फर वाचिङ।